Unfortunately, no one can be told what Kubernetes development is. You have to see it for yourself. Hello. Today's demo is all about how to get stuff done with Kubernetes as a developer. And really 10x, 100x, the sky's the limit, your development workflow, especially if you're creating something like microservices architecture or event-driven architecture. To do the right thing has to be extremely easy. Otherwise, right, you tend to just fall back to what you don't have to ask for permission for, or that you can get done with your local laptop. And that tends to be just put everything into the same code base. So what Kubernetes and a good platform on top of Kubernetes, like what we're going to be using today, OpenShift does, is give you day one without having to wait for anyone else. You can start creating those elegant architectures that you've been talking about maybe for a long time, but it above and beyond that, it makes it easy for you to create those architectures and really get stuff done. And even if you didn't have a SRE team or a DevOps team, as a developer, one of the things that you'll notice during this demo is at no point do I create containers from scratch or do anything like that. This platform lends itself to taking advantage of Kubernetes and creating software in a way that feels natural as a developer and allows you to do the right thing, and you can do it easily enough that you won't be tempted to fall back to doing it the easy way because maybe you had to ask for permission, or it just was too much work to figure out all the ins and outs of how you can create a distributed architecture. So without further ado, let's show the application that we're going to be creating the backend for today. It's a game called Into the Dungeon. I'm going to fire it up here. All right, so today we're going to be creating a backend for this game called Into the Dungeon. And the purpose of the game is to defeat as many monsters as you can and push your luck as they get progressively harder, and then choose to leave with the loot that you've collected before they get too hard for you to beat. And so then your score will be recorded on the number of rooms that you were able to complete before you left, as well as keep the cards that you collected and the loot that you acquired. And so let me just log in here. So it uses Red Hat Single Sign-On as its authentication mechanism. Once you're logged in, you can then go to Enter the Dungeon and pull in your Axie into the dungeon. Now, everything that you see that loads up on the screen, the monsters, the Axies, the dice, all of even the cards and the monster cards. So I'm going to roll some dice, and then the cards are going to be played for the monster. But all of this has a pretty nice data model that I created using Epicurio Studio and Microx, if you watched one of my earlier videos. And then from there, I was able to take advantage of a low-code, no-code system called Strapi, and I'm running all of this on OpenShift, and I'm able to develop this not just on my local environment, but taking advantage of the distributed nature of Keycloak to basically act, or not Keycloak, but Kubernetes and OpenShift to act as basically like 1,000 different application servers, if you will, or basically give me the easy button for doing the right thing when it comes to distributed microservice architecture, event-driven architecture. So as we go along here, everything's being loaded up by an API. So rather than just having everything come from a local Unity application or game, I'm able to drive new content with a pretty elegant architecture and back end. I need to beat this guy. And then I want to mention one other thing. So I'm going to take this guy as my reward, and I'm going to choose to leave at this point because I've acquired a card, and then we'll see and then the card is going to be used. I can go to the main menu, look at the leaderboard. Now, we didn't make it to the leaderboard because we only went through one room. But then, let's say we're to come in here and go to our deck manager. You can see this card I obtained, and it's now in something that would allow me to create a new deck. So I can come in here and choose to select that card, and then this card for a new deck so I can become more competitive. But I do this by sending messages to an AMQ message broker that I've also spun up myself as a developer. I didn't have to ask for permission. And then on top of that, I was able to consume those messages with something called a Camlet that I deployed with the Camel tool that integrated with my platform, my Kubernetes platform, to make the architecture that I'm creating much more resilient to failures of, let's say I was trying to just put everything into the back end and do, a RESTful asynchronous call, or even synchronous call that one shot, and if it doesn't go through, it just failed. So you've got to make those things that are the right thing to do, like create messages that then do these things and can retry. You need to make that process easier, really easy to do. Otherwise, you're going to fall back on doing the wrong thing. So that's what I'm going to show today, creating the backend for this that comprises all of those pieces that if you were trying to do that on your local environment, it would be virtually impossible. But you'll see that it's semi-trivial with something like Kubernetes and OpenShift. And so we'll be able to get a lot done today in a fairly short period of time. And I want to show you just how nice of an experience that is. So I've cleared everything out now. Let's try to spin up the game and see what happens. So if I click login, the first thing that happens is we go to an application not available because it's no longer there. And then if we were to go into the game, it wouldn't be able to serve anything up because the APIs and REST endpoints for the backend wouldn't be there either. All right. The first thing that we need to do is create a place for us to work. So I'm going to create a namespace called Enter the Dungeon. And now that I have that namespace, the next thing that I need to do is I have an existing database that has that whole data model of monsters and characters and cards and decks, and so I need to restore that. And that can be sometimes a difficult task, but in this case I'm going to use an operator. I'm going to go to the operator hub and look for CrunchyDB. So I've got a few options to choose from. I'm actually going to go with the certified operator. I'm going to go ahead and install that and click install. And then once that is ready, we can create an instance of a CrunchyDB backend or a CrunchyDB database. And then as part of that, I want to restore from an S3 bucket. So one of the nice things about using this operator is it takes backups and stores them into an S3 bucket automatically and makes it easy for you to, on first startup, import all of that without having to know a whole lot on what's going on. So I'm going to go and view the operator. I'm going to go and create an instance of this. And to do that, I'm going to copy and paste just a little bit of YAML. Again, I'm not getting down in the weeds of Docker files or anything like that, but I could use the form view, and this would give me a little bit of extra help. But if you do have some YAML, which I do, you can kind of jump to the exact settings that you're looking for. And of course, later on, once you're ready for your production pipeline, this can be turned, you can take advantage of OpenShift GitOps to sync your YAML rather than do this manually through the user interface. All right, so let me grab this. Actually, the first thing that I need to do is create a secret. So I don't think I have the secret necessary to pull from an S3 bucket. So let me go. Oh, actually, I did create this namespace once before in this example, AMQ secret. No, that's the AMQ secret. but I need to create a secret called S3 key. Is that in here? No. So I'm going to create a new secret. And I like how this gives me the ability to do this from YAML. And I'm going to copy and paste. So I'm going to take this off screen for a little bit because it actually has my access key and secret key in there. And paste that in, and then I'm just hitting create. And now I've created my S3 key. And later on, so by default, that is, so this is a secret is encrypted, and I can store this securely and inject that value into running containers later. Okay, so now that I have that S3 key, I'm going to go back to the installed operators, go to my crunchy Postgres, and then I'm going to create an instance. I'm going to go to YAML view, and then I'm going to copy and paste this entire thing. So copy and paste. All right, so this will give me a node port using the S3 key, and then it is going to restore from Strapi Postgres backup in US East 2, this bucket, and then I've given it its credentials via an S3 key, and then in the future it's going to be backing up what it does to a different bucket called Strapi Demo Backup, so that I don't overwrite the backup that I'm restoring from. So let me go ahead and hit create, and the first thing this thing is going to do is spend time restoring the data that is in that particular S3 bucket. So if we were to come in here and take a look at the logs, once they start populating, we can see what's going on, or any events that were to happen. So secret S3 key not found. So let me go back and look at, oh, did we create that S3 key in the wrong namespace? You have to be careful that you're looking at the top so that your S3 key is there. That you're adding your secret to the right location. Secret, yeah, we didn't add it to the right location. I added it to the open. So let me go back and add that secret. And the nice thing about this all being declarative is it will check again continuously. There's a pod that is checking because it's all being managed by an operator. So I'm going to go ahead and create this secret again. Make sure that I add it into the dungeon location. Okay, now that that's added, let's go back and take a look at the pods. And look at this, events. Let's go to logs now. And we might have to recreate this. And the nice thing about doing things with operators, so if we go to installed operators, go to CrunchyDB, Postgres. Actually, let's go to the S3 bucket to make sure that we're not going to stop this before it needs to be. Okay, let's go ahead and recreate this. So delete that, make sure the pods go away. It'll clean up after itself. And then I'm going to come back in here, go to Postgres, make sure our secret is still there. Yep, S3 key is there this time. Postgres, create Postgres, and I'll copy and paste. And this time the S3 key should be there. Let's go to pods here, go to events. All right. And I have OpenShift data foundations, but depending on where you deploy OpenShift, you will have dynamic storage classes that automatically attach the storage necessary. So in this cluster, I have under storage I've got these various storage classes, and by default it's using block storage to back up my Postgres CrunchyDB database. And as we go along, so this thing is restoring. And since it's the first time, it's just giving you a warning that says, hey, there's a few things missing. If there's any data in your backup location that we set, that it will fail. But since it's completely empty and this is the first time, it should be going now and adding to the S3 bucket a backup, automatic backup. So if we come and take a look at demo backup, so it'll take a little bit of time here. And once this is done, we will return and I'll show you the next steps. Okay, once that restore job completed, it immediately kicked off the running instance of a few things. One, the thing that will continue to do the backups in the future, as well as the database itself. And now if we come in here and hit refresh, so it created what it needed to take continuous backups in that S3 bucket that we told it to. So that's a nice thing that gets you ready as a developer for production. So it's much easier to hand off your work to the team that's going to be handling a production pipeline. All right, now that that is done, the next step is to create a service. So I need to create a service that would allow me to contact this database externally from something like pgadmin, as well as internally. So let me create this service. So on bare metal, copy. So I'm going to come into services, hit create service. So there was a service that was created that you could use to communicate with that automatically, but I'm creating another service that then would make this, that I'm going to use to make it accessible to the outside world using a node port. This is on bare metal, but it would be virtually the same thing if you were running in Amazon. You would use a load balancer and then be able to communicate using to your database using like something like pgadmin. So I'm going to go ahead and create that. And it's this service that I just created. Make sure that it's pointing to the pod that I want. It is. And so the very next step is we want to get that Red Hat single sign-on working again. What do? We come back again to our operators. And we look at SSO. So Red Hat single sign-on operator, we're going to go ahead and install. And that's done pretty quickly. We're going to create an instance of Keycloak. So Keycloak is the upstream of Red Hat single sign-on, so that's why you see that terminology there. And basically all you have to do is hit create, keep the defaults. I'm going to rename this to Strappy Keycloak. So I'm using this as basically an instance that will allow me to have the users that I'm going to keep track of and reference in my my RESTful backend implemented by Strappy. Okay, and let's go back and take a look at the pods that should be spinning up. Install the operators, go to Red Hat single sign-on, go to instance of Keycloak. So it's initializing, so you can go in here and look at the status. Let's go back to the pods. So what it's doing is it's actually spinning up its own database. So this operator is responsible for all of the work. So there's a pod that's acting as a controller that is checking the declarative nature of the YAML that it's given. And, we just use the default, and then it creates the Postgres database for keeping its data model, and that's completely separate from the database that we're running for Postgres, for Strapi. And then eventually this instance of Keycloak will come up. Once it's ready, you'll see one of one. And then we need to import our realm information. We're not going to import any existing users, but we'll import the realms so that we have the configuration necessary for our application. And we can go and look at the logs to see where it's at. And sometimes it might screw up just because of timing. So let me go and do this again. The nice thing is about that, you can delete that pod and then it should come up. Now that this database is in place. Let's go and take a look at the logs. It's looking healthier this time. All right, now that Keycloak is also up and running. It can take a little time for that to come up, but we do have routes associated with that. So if you wanted to, you could go right to the admin console and log in. Let's go ahead and do that, but we need to go and grab the secrets that we need, and these are okay to share because I won't be using those in the future. So let me take a look at the into the dungeon. So credential Strapi Keycloak. Let's reveal the values. Let's go with that, and let's go ahead, log in as admin. And we don't have the realm we need. We need to add the enter the dungeon realm. To do that, I'm going to select a file. I'm going to download a file that has what I need. And download that. And I'm going to go ahead and select that, open it up, and create. Okay, now that we have our realm, and you'll notice that all of these routes are being generated dynamically, but I have a wildcard cert that is valid for this particular domain. And so all of the routes that come up that are created by these various components, and everything's backed by containers, automatically have a valid certificate applied. So this is a secure connection, and I didn't have to know anything about that. It's just the cluster is providing, OpenShift is providing that for me in the way of that router that is injecting that valid certificate as we go along. All right, so let's see. Now we are going to take advantage of that Strapi database that we restored from, using the CrunchyDB database operator. We're actually going to deploy the application that's going to use that database now. And all of that is, I don't have any YAML. So that application is actually a Node.js application, and it has a package.json file. So, normally to get this thing containerized, I would have to know a thing or two about containerization. But because I'm using OpenShift, the nice thing is I can get this deployed without having to know anything about that, and still lend itself to becoming, putting it into a production pipeline later on using something like Argo CD, because we're going to take this approach. We're going to come in here, we're going to switch over to the developer view. And in the developer view, we have this thing that allows us to click add and then import from Git. And that Git repository just contains Node.js source code for Strapi. And what's nice about this is it will create, so I like to just I don't want to build pipelines up front. I don't want to think about, deploying to production. I just want to get stuff done. And this creates a very good start to that pipeline. Even though I'm not building it myself, if I follow this approach and take advantage of what's going on under the covers with source to image, there's builder images inside OpenShift now that know what to do with the source code that I give it. And so that source code I'm going to grab from this location. So copy, and it's going to complain that it can't get to it. So if I show my advanced Git options, I'm going to use, I'm going to create a secret. I'm going to call it GitLab. And it's going to be an SSH key. And I'm going to copy and paste that in a different screen because I don't want to share it with the whole world. Move this back over. All right, now that I have that, I can choose from a number of builder images. And I want Node.js because it's a Node.js application. I'm going to give it a name. The name is going to be Strappy. And sometimes, okay, so we're going to create the route, and I know that this is actually 1337. Okay, and I don't need advanced routing. Sometimes you have to go like this and make sure that you can. Okay, Strappy, and then go ahead and hit create. And what that will do, and you can use this in the future, this build config. The next time I change the source code to that, I don't have to have a really complex pipeline in order to get those changes back into a running image or even go through that process again. I can come into this build config, go to actions and hit start build. So build is already running for me. And if we go and take a look at the logs, right, I didn't have to build the Docker file. So normally, right, you see these steps that look like Docker file steps. I didn't have to, there's no Docker file anywhere. All I have is my source code. So that's getting deployed. And so it's not, so before it's getting deployed, it's doing a build. So this build is running, and then it's going to create the image, push it into the local registry. All of those things are done for me. And so at the very end, you'll see push successful. And we're just, so the build is still running. Take a look at the logs. And then once that is done, we'll have an image, and a deployment was created too. We can come in here and take a look at that. So if we go back to the admin view, those aren't necessarily things that a developer cares about. So we have to switch back to the admin view, take a look at workloads. And now we have this Strappy deployment that was also created for us. And then eventually, right, if you want this into a production pipeline, we can extract it and then put it into its own Git repository and use something like OpenShift GitOps, which is backed by Argo CD, to sync that in a production pipeline for that deployment step. And so allowing, as me, a developer working in this environment, that will allow that bridge to be, that gap between developer and operations to be bridged much more easily, because I'm doing and creating all of the things that will be the things that are running actually in production. So the build completed. So if we go back and look at the build, it was complete. Now it's doing a deployment. And if we take a look at the pods that are spinning up, so we've got a Strappy pod, and we can take a look at the logs. And so we have Strappy, into the dungeon.apps, itd, fjord, gpt.com. Like the Norwegian fjords. So that's the namespace of the cluster, and it created routes for us. And again, those routes are automatically secured by the cluster. So now we have a Strappy that's available. So if we were to log in and because I'm using the database that was restored from that CrunchyDB backup process. I have all of my information in here. So we can take a look at, we've got monsters and Monster Quest, monster rooms, player cards, and the card that is shared by that other. So we have a very nice data model that's backing that entire application. So if we go back to our game now, and if we click login, we're back to at least being able to log in. But now the Keycloak database I did not restore, so there aren't any users. So we're going to have to go ahead and register. So let's register with hello kitty. Hello kitty at enterthedungeon.com. Hello kitty. Okay. Register. Since we have both Red Hat Single Sign-On and the Strapi database working, we will at least have the regular gameplay. So the gameplay working that doesn't yet save the cards or the progress you make. So if we beat him, let's come in here, and then we'll collect a bolus. So we should have a second one. Let's try to get something unique so that we can definitely see it and see that it's not there when we finish. All right. Let's see. No, we've got the laculum. Let's do one more. All right. Let's see. Maybe this will give us 2 morning stars, but we already had a morning star. Oh, I forgot. I gotta click one more time. Beat this guy really quick. All right. And we'll get the snail shield, and we'll leave. All right, we are supposed to have collected 4 of these items, but what we'll notice is that when we go to the main menu now, and I'm running it without the sound being recorded, if we come in and take a look at our deck manager, we still have just our original deck that was created when we created the user. So now we have to implement the message-driven architecture. The game is sending messages, but they don't have any place to go. So we're going to create a project that's going to contain our AMQ message broker. I'm going to call that AMQ broker Enter the Dungeon. And the steps that we take are pretty simple as well. We're going to come in here, go to operators. We're going to look for AMQ. And we need the Red Hat integration AMQ broker for RHEL 8 multi-arc. We're going to install. The defaults are fine. This is going to create the operator that will allow us to generate, so it will manage the instances of the brokers that we spin up. So we're going to spin up just one broker for this demo. We're going to come in here and hit create active MQ Artemis. And actually, before we do that, though, we need some secrets. And I did generate some secrets that we're going to need. I generated some certs that we're going to need in another directory. Okay. So we do need that secret, and then we're also now going to create the instance of the broker. Create These are the settings. We want AMQP as our protocol. It's going to use the secret that we just created. And then that's pretty much it. We also want to make sure that it is exposed via a route. So we're going to go ahead and hit create. And wait for that to get installed. All right, that didn't take too long. Now to create the actual queues, it's pretty simple as well. We come back in here. So all of these custom resources, these custom resource definitions are being managed by the AMQ broker operator. And all we have to do is come in and say, okay, I want an AMQ broker address. I'm going to create that the same way that I created the actual broker itself by a little bit of YAML. So there's three queues that I'm going to create. I'm going to create the player cards address. So it's going to, or player cards events, create. I'm going to create another one. I'm going to create the left dungeon events queue. I'm going to create one more. And it is going to be the player cards lost events. All right, now we've got 3 addresses and we have our AMQ broker running. There's going to be 2 routes that were created for us. One is the service where you can actually communicate to the broker externally. And then here's where the management console would be. And we could log into the management console if we wanted to. We could extract the secret that was generated that would allow us to log in. And we probably should do that because we're going to need it. So if we come in and take a look at the, which one was it? It's going to be the AAO credentials secret. And then we need these guys here, reveal values. We've got to have the AMQ user and the AMQ password. We'll use that later on, but now we have to switch and go to the OpenShift operators namespace. OpenShift operators. And we're going to install, so we do have some place to send our messages, but we don't have anything yet that can consume them and do something with those messages. For that, we will be using a camlet that I've already created. And if we come in here, go to operator, and in order to use that, we need to install another operator, and we'll look for the camel K. So camel K operator. But we want to use the Red Hat integration version of it. So camel K, this guy here, we're going to install it. All namespaces. Yeah, go ahead and install that. So we have to create an integration platform. What we need to do, we'll go OC project OpenShift operators. We have to modify it slightly so that we can use something called Jetpack that allows us to have a shared library and pull that shared library that we create ourselves rather than just searching Maven. So now we have an integration platform that is ready. We need to clone a repository. And we're going to do git clone. Oops. Control A. Try again. And then we're going to go to camel player. All right. So what this is a pretty simple one class that just runs using the camel K system inside OpenShift. So we'll use one line to deploy it, and it will just sit there and consume messages. So whether or not the player has left, whether or not a player card has been won. So every round and you're fighting the monster, you get a card, a message gets sent, and it gets stored in these tracked cards with the dungeon ID. And then when the player leaves, it goes through that list and then posts so that those cards get added to the player's collection and then can be used in subsequent rounds. All right, so let's go ahead and deploy this. To do that, we need to replace, so copy a few things in the configs here. We'll paste that. And then in the AMQ consumer, we do need to change this. This will be, all right. And then there is one line that we have to run. Copy, come in here, and we're going to deploy that now. Okay, I think we should be good. And that's created. And if we go and look at our integrations, we've got a running integration. Go to resources, a deployment, take a look at the pod, and let's look to see if the pod looks healthy. So we should have it where it says that it's listening. So AMQ started route 1 and started route 2, and it is listening and successfully connected. All right, let's go ahead and retry our game and see if we get some player cards that get stored for use in later games. Okay, we're playing to win now. We're going to enter the dungeon. Okay, this is all we have for our player cards that we can put into our initial hand. Let's go try to win some more. Okay, he got a 5 to our 1. Well, this might take a lot of our cards. I'm hoping to win at least twice. I don't want, I'll take that one. Okay, let's go to the next room. Oh, 5 again? Are you kidding me? All right. Okay, what are we going to win? All right, Laculum. I'm going to take it. Let's leave the dungeon now. And what you'll notice in our AMQ consumer, we've been getting messages sent meanwhile, so that when we come over here and go to the main menu, go back and take a look at our deck manager, now those messages have actually sent to, they were sent by the game to the AMQ broker, and then our application, our little Quarkus Java file that was deployed with one command at the command line using the camel CLI is now consuming those messages and then communicating with that same Strapi database only via that event-driven architecture. So that's going to be a lot more resilient than if we had just done the easy thing and made another REST request via straight to the Strapi endpoint. That's going to make it easier to secure those endpoints and not talk directly to the database yet, but instead put that that intermediary with the event-driven camel integration point in place. So that worked pretty well. We were able to gain a scutum and a laculum, and we could use those in the in the next game. We could create a deck out of this, up to 10 cards. So we don't have 10 cards to create, but we could save that. So enter a name for the deck. That deck would be Second Hand. And go ahead and save that. All right, we're going to go hit back. Previous. We could use our second hand now and play the game. And now we have to start out with a laculum and a scutum instead. All right, so this has been an example of how you can quickly generate a very nice implementation with newer architectural approaches using event-driven architecture as well as low code. You can just deploy all of these different distributed components easily with the help of Kubernetes, as opposed to imagine trying to do that on your local laptop with all the different moving parts. That would be pretty difficult. All right, so hopefully you see the power that OpenShift and Kubernetes provides, and you'll also be motivated, like me, to take advantage of the being in the architect's mindset that allows you to accomplish more with OpenShift. All right, thank you.